pre-processing, post-processing, and so on. And Internet of Things, high performance computing, and Altair product. And this is the global customer, 15,000 customer worldwide, in different industrial segments like automotive, education, engineering sector, government sector, industrial goods, material supply, and technology. So today's agenda, so we have planned to showcase capabilities of Altair, like multibody dynamics, meshless technology, structural analysis, optimization technology, multiphysics using SimLab, sheet forming and casting simulation, physics AI, power electronics and motor drives, data analytics and artificial intelligence, and physics simulation. So we will start with multibody dynamics. So multibody dynamics is nothing but study of motion when the bodies are interconnected by means of joints with or without application of external load. So in multibody dynamics, we have four step process. One is assemble, second one is solve, third one is evaluate, and fourth one is improve. So in assemble, we will import the CAD model, we will apply the contact, we will apply the force, and then we will make the model to run for the analysis. In solve, we will solve the problem with different equations, and this MBD simulation can be coupled with computational fluid dynamics, can be coupled with structural 1D simulation, control system, and so on. Coming post processing can be done with the help of hyperview and hypergraph. So whatever the analysis results, such as deformation results, stress plot, strain plot, deformation, velocity, acceleration, displacement, everything you will be able to get it from hyperview and hypergraph. And it has view like animation view vector force also you will be able to generate, as well as you will be able to generate the graphs for all the output. And fourth step is the improvement. After multibody dynamic simulation, the result, if it meets the performance, well and good. If it doesn't met the performance, DOE study, design of experiment and optimization. So we have to create the design variables, we have to create the constraints, and we have to create the objective. Based on that, software will suggest as solution. And flux body generation, so flux body is one of the important aspect in multibody dynamics, where if the user want to get the stress and strain plot during the dynamic condition in mechanism itself, so they can use flux body simulation. So by using component mode synthesis method, they can incorporate this flux body in multibody dynamic simulation, and they can get the stress and strain output. Some of the automotive case studies which I want to showcase to you, like we have done one of the case study for Toyota Japan. It is the development of electric car. Okay, so they have used multibody motion solve as a tool for multibody dynamics simulation, and they have performed the simulation as well as experimental test. Okay, the one which you are seeing on the left side is the simulation result, on the one you are seeing on the right side is the experimental result. So after performing the MBD simulation, the stress plot, the stress and deformation they have derived from the multibody dynamic simulation has been carried forward for the fatigue analysis in order to determine the life cycle of the component. So this is an example for landing gear mechanism. So here we are applying the motion and we are determining the force that is acting on the strut of the landing gear. So this is another example of engine simulation and landing gear simulation. And this is an example for Conrod mechanism of aircraft. So here we want to design the actuator size So we want to know what is the load that is exactly acting on the actuator. So based on that, we will design the size of the actuator. So coming to meshless technology, SimSolid. So SimSolid is the meshless technology which eliminates the pre-processing work and reduces the time of iteration very drastically. So it works directly at the design phase. So design engineers can do multiple iterations before doing the final FEA validation, and so the time consumption for solving the problem will be very minimal. So from if you take in FEA, it will take 1 hour. You can solve in SimSolid within seconds. So that is the speed of SimSolid. So different types of analysis you can perform using SimSolid, such as linear static analysis, a nonlinear static analysis, bold pretension, inertial relief, and thermal analysis, modal analysis to determine the natural frequency of the component, frequency response analysis to determine the excitation frequency, transient response analysis, and random response analysis. So apart from that, you have auto connection. So directly after importing the model, you can directly create the connection automatically with the help of auto connection, and you can apply different types of contact like bonded contact, sliding contact, separating contact with friction, and so on. And you have bold pretension option where you can apply the bold pretension, tightening torque, everything you will be able to apply on the model directly. And you will be able to create spot weld, seam weld, and virtual connectors, etc. with SimSolid. So these are the some of the examples of contours, like for frequency and mode shape, and for static analysis, and for buckling analysis. So you will be able to calculate the modal participation factor, and force, reaction force that is acting on the bolt, and factor of safety for the component, and so on. So SimSolid is very fast and very easy to learn, and it is uh, you can perform multiple iterations in a shorter time duration to get the results it at the earlier stage of the design process. Coming to structural analysis, we have OptiStruct for structural simulation, which can perform stiffness, strength, and stability analysis, noise and vibration, as well as acoustic simulation, powertrain and durability. You can determine the life cycle of the component, and you can perform thermal analysis, be it static as well as transient thermal simulation, and kinematics. Along with that, you can perform optimization as well. So it supports linear and non-linear materials like isotropic, orthotropic, and anisotropic material, elastoplastic material with isotropic, kinematic hardening, and so on. And it supports gasket material as well as hyperelastic material. And you can define small as well as large displacement formulation for nonlinear analysis. Contact definition, you can define different types of contact definition like gap elements, contact elements, slide stick, freeze, friction, no separation, and so on. These are the like thermal effect. You can include the thermal effect by using the thermal dependent structural material properties, and preloading the load from the previous load case can be carry forward to the preceding load case, like buckling analysis, frequency response analysis, or transient response analysis. You can perform the preloading conditions. And subcase continuation, you can change the loads and boundary condition from one load case to another load case by using changing or you can change the component, or you can change the contact, and so on. And it supports all type of element like solid element, shell element, beam element, bar element, bushing element, contact, and payload, etc. Hyperelastic material, it supports neo-Hookean, Moni-Revelian, Yeo material model, reduced polynomial, Ogden material model, and so on. So the contact you can perform like node to surface contact or surface to surface contact. Both the contacts are available in Autostruct, and the output what you will be getting from the contact simulation is like penetration, open and close status, force, stick and slide status, frictional traction, and so on. So coming to NVH, so you can perform different types of NVH simulation like modal, direct and yeah, direct and buckling, as well as CMS method, random response analysis, acoustic analysis, modal, panel, structural, grid participation using H3D. And powertrain durability, you can create 1D and 3D bolt pretension, gasket modeling, and plasticity. And durability analysis, with the help of Dangwang criterion, you can determine the factor of safety of the component, as well as you can determine the life cycle of the component. Hyperlife is the tool which helps the engineers to perform the durability analysis to determine the life cycle of the component. And heat transfer, you can perform conduction, convection, radiation, as well as thermal coupled structural simulation with transient condition can be performed using Optostruct. Coming to Optostruct optimization. So Optostruct optimization is the industry proven structural analysis solver for linear and nonlinear problems. It is the market leader for structural design and optimization, and it uses advanced optimization algorithms for developing innovative, lightweight, and structurally efficient design. And you can analyze and optimize strength, durability, NVH performance of the component by using Optostruct optimization. So what are all the different types of optimization you can perform using Optostruct? So you can perform static and dynamic optimization, you can perform vibration and acoustic optimization, and you can perform optimization on life cycle of the component, and also you can perform optimization on composite material and multiphysics. So these are the different types of optimization technique that are available in Optostruct, like topology optimization, optimizing the optimized material distribution, free size optimization, topography optimization, free shape optimization, shape optimization, and size optimization. So coming to topology optimization will give you the optimized material layout based on the given loads and boundary condition. Thereby you can reduce the weight of the component without compromising the strength of the product. So it works on density based method. So you can define different types of manufacturing constraints like minimum and maximum member size, draw direction, extrusion constraint, symmetry constraint, pattern repetition, cyclic symmetric repetition, no hole casting, stamping, and so on. So once you perform the optimization, you will be able to get the optimized material layout in the form of step, parasolid, IGS, STL, and H3D file formats. So this can be further imported to any CAD modeling tool for design fine-tuning purpose. Coming to topography optimization. So in order to improve the stiffness of the sheet metal component, you can use topography optimization. So you will get an optimized bead pattern from the topography optimization. This is an example for one of the from one of the customer. Like this is the oil pan. uh, I want to optimize the stiffness of the component. So the initial design has the different configuration. After topography optimization, we got the new bead pattern. Thereby the frequency of the component from initial design to optimized design, it has been increased from 660 hertz to 300 hertz. And this is another example of door slam mechanism where we have we have reduced the displacement by 90% through topography optimization. And coming to shape optimization, so shape optimization will help to optimize the shape of the component. So you have to create the shape variables through morphing, so which is available in hypermesh. So after creating the shape variables, you can define shape variables as a design variable in shape optimization. Based on that, you will get the optimized shape of the component. For example, this is the seat belt retractor bracket. So here we have defined the shape variables. So based on the shape optimization, we are able to reduce the stress from 400 MPa to 337 MPa through shape optimization. And free shape optimization works based on the node perturbation. So this is an example of connecting rod. So it has analysis setup with interference fit, bolt pretension, contact with friction, and bearing pressure load. Here the design constraint is stress, and the objective is to minimize the volume. And we have defined one plane symmetry. So now you can see the weight is unchanged, and the stress violation is eliminated by 54%, and the life has been improved drastically. Coming to composite optimization. So here, if you want to optimize the composite laminate, then you can go for composite optimization. So this is the initial design. So the first step in composite optimization is free size optimization. So after free size optimization, you will be performing ply size slicing. So once the ply sizing is done, we will be performing the size optimization. After size optimization, shuffling, then you will be performing the final, you will be getting the final output design. So this is an example of underbelly fairing optimization, which has been done for Airbus. Coming to SimLab multiphysics. So SimLab is a powerful multiphysics simulation tool where you can perform structural coupled thermal simulation, thermal coupled CFD simulation, electromagnetic coupled thermal simulation, or electromagnetic coupled structural simulation. So here in this case study, we have taken electric motor multiphysics. So in electric motor multiphysics, we can perform electromagnetic simulation, and we will get the electromagnetic output such as losses and the force, electromagnetic force, which can be used further for performing the acoustic analysis and the thermal analysis. So in this schematic diagram, you can see first we are creating the sketch, and then we are modeling it, and then we are performing the electromagnetic simulation. From the electromagnetic simulation, we are determining the electromagnetic force. So from the electromagnetic force, we are performing the acoustic vibroacoustic simulation, where we can determine the noise level on the motor that is generated by the motor, and the losses, whatever the losses during the electromagnetic simulation, can be transferred as a thermal load to the CFD simulation, and we can perform the thermal simulation, where you can determine the temperature distribution across different components of the motor. So you can map the load in a single click from one physics to another physics. Let's say you are performing electromagnetic simulation, and you want to transfer the load from electromagnetic simulation to CFD simulation. In a single click, you will be able to transfer the load, and you can perform the CFD simulation. In similar way, if you want to transfer the load from CFD simulation to NVH simulation, In a single click you will be able to transfer those loads. This is an example for valve. So where we are applying the um, pressure load and inflow and outflow, as well as mass flow rate, etc. And here we are determining, in CFD simulation we are determining the pressure that is generated on the valve. Those pressure has been mapped to the structural analysis in order to perform the in order to get the structural output. So like pre-stress load as well as the mapped pressure, both combined together, we are able to see the displacement and stresses on the component. So it is fluid coupled structural simulation. And coming to Inspire Form, so Inspire Form is the sheet metal forming simulation tool where you can perform different types of sheet metal forming simulations, such as one step forming as well as incremental analysis. You will be able to get the formability limit diagram where you can determine the wrinkleness and strain region, thinning, thickening, and so on. uh, Along with that you will be able to unblank and nest the pattern and so on. So this is an GUI of Inspire Form. So whatever you are seeing is nothing but the formability limit diagram, which shows the thinning, thickening, failure region, plastic strain, major strain, etc. So in feasibility analysis, you can import the CAD model. No meshing is required. It has inbuilt database with different standards such as US standard, Japanese standard, or European standard, and you can do automatic orientation of the material with undercut to minimize the undercut. Applying the blank holding force and draw beats is very simple in Inspire Form, and you can visualize the thinning and formability, strain, etc. So this is the procedure in Inspire Form. First you need to import the geometry, set up the model, run the analysis, formability analysis, and then flatten and fit the blank, and then finally nest the blanks. This simple video explains how you can perform one step formability analysis. So first we are defining the undercut region, and we are removing the undercut region, and then we are defining the orientation to the part. So once you define the orientation, you can define the uh, blank holder surface. So after defining the blank holder surface, you can directly run the simulation. So once you run the simulation, you will be able to get the formability uh, uh, result. Like this is the formability limit diagram, which you can see here. So you, with the help of callout, you will be able to determine the failure zone or thinning, thickening, and so on. Okay. So after performing the simulation, after viewing the result, you can perform the unblanking and nesting. So it will give you the optimized nesting pattern where you can eliminate your wastage. And coming to virtual tryout analysis, virtual tryout analysis is useful for uh, uh, forming and spring back analysis. So in a single environment, you will be able to perform single stage as well as multi-stage stamping simulation. You will be able to determine thinning, strain, stress, failure contours, and also formability limit diagram. So along with that, you will be able to get the tool force versus stroke plot within the simulation. So this is the general procedure. So first you need to import the model, set up the drawing, analyze the drawing, and run the trimming and spring back, and analyze the spring back simulation. So this is the sample demonstration video which explains how to perform the incremental analysis. So here we are selecting single action. So based on that, you will be able to get the punch and die and trimming process. So you are selecting the trimming lines and setting up the spring back and running the simulation. So you have to apply the force tonnage. So this is the output of the simulation. So you will be able to get the thickness, formability, failure, plastic strain, and also tool force versus uh, stroke length, etc. Okay. So coming to Inspire Cast is the casting simulation tool which helps the design engineers to predict the casting defects at the earlier stage of the design cycle. So you can perform different types of casting simulations such as high pressure die casting, low pressure die casting, inversion casting, and sand casting, and so on. So it has intuitive rigging components for casting simulation. In a single click, you will be able to generate core and molds, and it has auto creation of razor with full control of on-screen manipulation of size of the razor. And it has guided template for most of the casting simulation process like sand casting, high pressure die casting, low pressure die casting, and so on. So this is the 5 simple step. First, you need to import the CAD model and you need to define the gatings, and then you need to import the secondary components, set up the process, what type of process is that, whether it is high pressure die casting or low pressure die casting or gravity die casting, and so on, and run the simulation. So these are the output which you will be able to get it from the simulation, like filling time and front floor temperature distribution, velocity plot, filling time. You can take cut section and you can see the uh, um, uh, solidification or cold shirts that are present in the model, and also you can see the pressure distribution, air entrapments, and liquid fraction, solidification time, and total porosity. So coming to Altair Physics AI. So Altair Physics AI is the environment or tool for predicting the result with the help of artificial intelligence from the simulation result. So I have set of simulation results, and from based on the list of set of simulation result, I want to predict the result for the new design. Then I will be using Physics AI. So what I need to do is, first I need to create the project, and then we need to create the data set. So I will be creating list of data set from the previous simulation, and then I will do the model training, and then model testing. Finally we will predict the result for the new design. So this is an example of HVAC. So from the simulation, from the physics AI, we are able to determine the pressure distribution for the new design without performing the CAE simulation. So here we are eliminating the complete CAE simulation process like meshing, application of loads and boundary condition, and so on. Okay, so this is the output. This is the output which you will be able to determine in a single window. You will be able to get the result for the predicted result for the new design. And this is an example of a case study of Magna crash box. So generally they used to spend 14 hours time duration for simulating the crash box. So this does not allow them to explore more designs. So they used hyperstudy for synthetic data generation, and Altair Physics AI for fast physics prediction. So by using Physics AI, they are able to get the simulation result within 10 seconds from 14 hours. So that is the drastic time reduction what they achieved using Physics AI. This is another example of hero. Here they have performed the prediction of handlebar. So they have applied the loads and boundary condition, and they have got the simulated result, set of simulated result. Based on the simulated result, they have predicted the result. So the result prediction time is 10 second from 1 hour, which takes for CAE. Coming to power electronics and motor drive simulation. So PSIM is the tool which helps the design engineers to design and simulate power electronics and motor drives. It enables the rapid development of motor drives, power supply, EMI, EMC compliances. It is well recognized for simulation speed, accuracy, and simulation robustness. So PSIM accept design modules from smart control design suites like power supply, EMI, motor control, EHV, HEV, etc. And implementers like TIMCU, Model Sim, Typhoon HL, etc. Okay, so PSIM performs different types of simulation, like power converter simulation, loss computational, non-ideal switching modes, analog and digital control, auto code generation, scripting capabilities, etc. It can interface with Activate, Flux, LT Spice, and third-party software. So coming to electrification, so we have electrification in every domain, like structural, fluid dynamics, multiphysics, multibody dynamics, power electronics, battery system design, motor design, and so on. So here PSIM plays vital role in power electronics. So the battery management, inverter control system, motor control system, so everything can be managed with the help of PSIM. Coming to power supply design, we have schematic, parasitic, thermal, and PCB boards. So the solution for all the four can be enabled with PSIM, Flux and Peak, SimLab, and Polex. So PSIM for schematic, Flux Peak for parasitic, and SimLab for thermal, and Polex for PCB board designs. Similarly, you can perform uh, simulation for that is fast integration solution for motor design and motor control, like system integration and testing, control design, and motor and multiphysics simulation. So you can see for system and control simulation, you have Activate. For code generation, you have Embed. And for motor control design, you have PSIM, and which can be coupled with Flux and SimLab for CFD, and Flux for electromagnetic simulation. So coming to data analytics. So data analytics is a three-stage process. In the first stage is the data preparation, and second stage is the data mining and predictive analysis, and the third stage is data visualization, data monitoring, data analysis, data optimization, and so on. So Altair provides solution for data analytics, end-to-end solution. Like Altair Monarch is this module which helps the data engineers to prepare the data. So it converts the unstructured data into structured data. So the structured data may be in the form of raw format like PDF, text, or Excel, and so on. So it converts the unstructured data into a structured data. And coming to data mining and data predictive analytics. Knowledge Studio is the tool that performs the data mining and data prediction. So it, with the help of AI and ML's algorithms, whatever the data received from the Monarch, it performs the um, model testing, model training, model testing, and then prediction, and so on. Coming to real-time data visualization, so Panopticon. So Panopticon is the solution which helps the data engineers to monitor the data, investigate the data, back test the data, and optimize the data. So Altair has recently acquired world-leading data science platform called RapidMiner. It has been globally used by 40,000 organizations, 4,000 universities, and 500 plus clients. And it is ranked one for data, that is manufacturing data analytics in 2023. So it is a single platform for the complete data analytics uh, uh, simulation, like data preparation, model building, model ops, and visualization. Everything can be performed in a single environment with the help of RapidMiner. Okay. Coming to physics simulation, so Altair has different types of physics simulation, be it from structural, thermal, CFD, multibody dynamics. So Altair OptiStruct is the structural linear nonlinear solver, which can perform different types of structural simulation like static model, buckling, nonlinear analysis, contact simulation, noise and vibration, random vibration, etc. And coming to Radius is the tool for crash and impact simulation. So if you want to perform full vehicle test with dummies placed along with seat belt mechanism, retractor mechanism, and so on, so you can use Radius for those application. So, and coming to multi-scale designer, so multi-scale designer is the tool for simulation of composite material, so where you can predict the material, you can do the material characterization, and you can get the material properties out of the simulation. If you have new material, you can model the material, you can run the simulation, and you can get the property of those composite material from the multi-scale designer. And also you can perform structural simulation as well. Coming to multi-body dynamics, motion solve is the tool for multi-body dynamics, as I have explained earlier. So this particular tool helps the design engineers to perform the MBD simulation. And coming to granular material simulation, EDEM. So EDEM is the discrete element method simulation tool. It supports granular simulation of granular materials like coal, uh, mined ores, soil, grind powders, etc. So it can be used in different industrial sectors like mining industry, pharma industry, heavy equipment industry, and agricultural industry, and so on. Coming to computational fluid dynamics, Accusol is the computational fluid dynamics solver, which can perform heat transfer analysis, flow simulation, turbulence modeling, etc. So you can perform thermal analysis such as conduction, convection, radiation, uh, and so on. And nanofluidex. So nanofluidex is the tool for uh, simulation of uh, uh, gearbox, gearbox and sloshing. Suppose you have a gearbox along with oil. If you want to perform the simulation and you want to see the flow of the fluid inside the gearbox, so those kind of simulation you can perform. Along with that, you can perform sloshing effect, sloshing of the fluid inside the container. So those kind of studies you can perform using nanofluidex. Coming to ultrafluidex is ultra fast prediction of aerodynamic properties of the vehicle, and it uses GPU. So it is much more faster when compared to the normal CAE tools. Coming to Altair Flux is the low frequency electromagnetic simulation tool which helps the engineers to predict the or perform the electromagnetic simulation. You can perform magnetic static simulation, steady state, transient condition, and also along with electrical and thermal properties. And FICO is for high frequency electromagnetic application. So you can perform RCS design and electromagnetic compatibility, electromagnetic interference, antenna design, etc. using FICO. And WinProp is the wave propagation and network planning simulation tool, especially used for network planning of 5G LTE WLAN, and it has wide range of scenarios and map data support. Coming to Altair Polex is the module for PCB thermal design. So you can investigate signal PCB signal integrity, and you can perform thermal simulation, as well as it has powerful set of PCB design verification tool that ensures the PCB design is proper. Coming to hyperstudy is the multidisciplinary optimization tool which helps the engineers to engineers to perform design exploration, optimization, stochastic study, and uh, um, meta modeling, and so on. So this can sit on the top of any solver. So you can couple with structural, you can couple with thermal, you can couple with CFD, you can couple with multi-body dynamics to perform optimization and design of experiment study, and so on. So with this I came to the end of my presentation. So now we can take a Q&A session. Amar.
Yes, Prabhu, I'm here.
Yeah,
Thank you
now.
for the presentation. It was a great, very much explanatory. All solutions were very much explanatory. So I have one question. I have one question from Mr. Aditya. He is asking, in stress analysis, is it possible to apply the load on a particular area or target area?
Yes, it is possible. So once you mesh the model, you can specify those, you can select those region, and you can apply the required load. So that is possible, absolutely possible.
Okay. Thank you, Prabhu. So I request all the attendees, you can unmute yourself and you can ask your questions. If you have any questions, you can either raise your hand and ask a question or type the question in the chat window. Subhashi sir, do you have any question?
Hello.
Yes,
Hello.
sir.
Sir, I would like to ask that in AccuSolve, we are performing some external aerodynamic simulation.
Yes, sir.
So,
Yes.
what is the difference that Ultra Fluidex and AccuSolve aerodynamic simulation can
So
make?
the difference between Accusol and Ultrafluidex, Accusol is a finite element modeling tool. So finite element, it uses finite element method, but Ultrafluidex is like it is also a finite element method, but it uses GPU for solving the problem. So the solving time for this particular ultrafluidics is much more faster than compared to that of accusol. Since it is uses GPU, so the solving time will be much more faster. It, like, you can use this for quick design predictions.
Okay. Okay, thanks.
Yeah.
Uh, Hello. Can you explain more
Yes.
about physics AI?
Yeah. Yeah, actually, see, we have set of data. Generally, if you want to perform CAE simulation, you have three stages. One is pre-processing, solving, post-processing, and then in post-processing, you will be able to get the stress plot, strain plot, deformation, everything. But let's say you have set of CAE data. Let's say 10 set of CAE data. Already you have run the simulation and you got the result, and there is a new design in the same line. You are getting a new design and you want to predict the result without performing the CAE simulation. So no need of meshing, no need of loads and boundary application of loads and boundary condition. Directly you can predict the result from the set of 10 set of existing CAE data. So with the help of physics AI, so it uses artificial intelligence and machine learning. So what you need to do is, first you need to give the set of 10 set of data to physics AI, and based the physics AI will read the entire set of data. What are all the stress, what are all the loads that has been applied, and what are all the different stress contour that has been arrived, and what is the deformation, everything it will read from 10 models. And uh, based on the 10 model, whatever the model you are giving as a new design, so it will predict the result to the new design. Based on the uh, existing data, you are predicting the result to the new design without going for CAE. You're
Okay.
able
And
to
yes, yes. And what about the data set? Like how many, 10 or 20, or how do we that how
see.
do we know like that is sufficient?
Yeah, generally you can use 5 to 10 set of data. Even if you don't have data set, you can create synthetic data by using hyperstudy.
Okay.
So that is possible. If you have if you have one or two set of data, based on that, if you want to create multiple data set by using hyperstudy, you can do that. You can get that multiple datas.
Okay. Thank you.
Okay, so Prabhu, shall we move to the next question?
Yes, yes.
The next question is from Ms. Dipshika Singh. She's asking how we take stress concentration factor during stress analysis.
Stress concentration factor.
Yeah, during stress analysis.
Yeah, generally when you perform structural simulation, the stress concentration factor is like wherever you have sharp corner or wherever you have uh, small features where the high pressure or high load is applied, you will get stress concentration over there. Generally you have to check the mesh at that particular location, whether the mesh is correct or not, whether the element quality on that location is proper or not, whether it is meshed with proper mesh pattern. So by considering all these things, you can see the like you can consider the mesh concentration. Even if you want to recheck, you can minimize the element size, or you can once or twice you can minimize the element size, and you can rerun the simulation, and you can check whether you are getting the same stress at that particular location, so that thereby you can confirm whether the stress concentration that has happened on that particular location is because of the application of load or because of the element. Based on that, you can consider the stress concentration. Yes.
Sir, during fatigue analysis, what criteria we will use like Soderbergh and Goodman for ductile and bitter material,
Yes,
or
yes.
something else we will use in practical application?
No, we have different methods. Like as you said, Soderbergh method is there, Gieber method is there, Bolt,
Goodman.
Goodman method is there. So different types of. So based on the different types of application, you can use the specific methods.
Okay, so Prabhu, we have another question from Mr. Shiva Kumar. Is it
Okay.
possible to make 3D modeling and 2D drafting in the same software, or do we have to purchase 3D and 2D making software separately?
See, actually, Altair solution is a CE simulation platform where it supports 3D modeling as a non-parametric model. So you can do 3D model in terms of extrusion or revolve. So those kind of small features are available in Altair, but dedicated if you want to go for dedicated 3D modeling and drafting, you have to go for 3D modeling tool only.
Right, right. So there are no other questions in the question tab. I request all the attendees, if you have any question, you can unmute yourself and ask the question. Also, I would like to inform you everyone at the end of the session, I'll be circulating the webinar recording with everyone, and at that time you can also revert with your questions, and we'll try to answer them later on. So Prabhu, I guess there are no other questions. So we'd like to conclude this webinar. I thank everyone for attending this webinar, giving out your time and attending this webinar. And thank you, Prabhu, for such an explanatory webinar. Thank you, everyone.
Thank you, Amar. Thank you all for attending the webinar. Thank you.
Thank you so much.
Yeah.